Okay, so the last time we had left off with the we had finished up the whack-a-moles, so that works now. We'll do a quick demo of how that looks. Yeah, the last meeting we had Corbin, right? So you guys were here or have watched the video on YouTube. Corbin was here to talk about Vue.js, and we hooked up a WebGL plugin to allow us to use the Unity WebGL builds into the Vue website that he had built right here during his live coding session. So I just want to go over the game real quick, what it looks like and stuff like that, so everybody kind of remembers. And then I would like to start a new game project, right? So I'm still trying to think of like what we should do. So totally up for discussion. So this is the game. I'm gonna turn this down. So that's a little tap on it. There are points right here. And this goes on for like 30 seconds, right? And then after that, the game over screen shows up, and then everything is done at this point, right? So now that we're done with this, and we know that we can build to WebGL, and we can build to Android and other things like that. So you can see here it says game over. We can either hit restart, game restart, we can hit home, so we'll go home, stuff like that. So this is obviously on GitHub, so you can look at it and then, you know, play around with it, change things. So, so now I want to tackle a new type of game. And this game that I want to tackle, I want to focus more on state machines. All right. The reason why I want to focus on state machines is because when working with like, you know, simple games and stuff, something that's not so crazy, having a good understanding of how a state machine works, how to transition and stuff like that, is the basis of building up some what we call weak AI. And by building on weak AI, we can actually have some, you know, basic enemies that we can build, or even like, you know, a friendly, an ally, or whatever. So, you know, so we can look up some games or some style of games. So I know on Discord somebody had said something about maybe doing a platformer. I had suggested maybe a top-down, you know, 2D shooter kind of thing. So let's look at what a top-down shooter looks like. So let's look at some popular ones here. So this looks pretty cool. I want to see. Yeah, you know, top-down games, they're pretty, you know, basic, and they're fun. What is this? Okay, so this is perfect. This has a lot of pretty colors. So let's try and look at this. So this is on the PlayStation. So let's see what this looks like.
With Alienation, we wanted to take a step forward in the evolution of the arcade twin-stick shooters, and also take the next step in a Housemarque explosive quest for relentless and addictive white-knuckle gaming.
So on mine it looks good because you guys are what's it called, screen capturing, but I think you guys get the idea here. So it looks like you're like this character. Like, cool, you have a map. So you have a character. I'm assuming you're the blue one, and the green one is probably like an ally. And you're just going around, you know, So this looks pretty cool, right? So looks like you have a laser. I don't know if the laser is what's being used or it's just a targeting. Okay, so it's probably the
Your mission is simple. You have
okay, so this is very cool. So I like this. Now, so you'd be surprised of how much actually goes into building something like this. But also you'd be surprised on how quickly we can actually build it using Unity, right? So this is, of course, one option that we can go down, right? I even found some free assets, and I found a package that has a bunch of characters with weapons and animations for like 25 bucks. So I might just buy that. And then we have soldiers. And there's another one that has like zombies, so we can create soldiers. We can do a couple things. Either the game would be like you're a soldier, different types, like you have specialists, you have like a rifleman, you have maybe a sniper rifle or a medic. And then I found a asset pack that has a bunch of zombies, so we can do it where like you're like the soldier, and then maybe you attack zombies, or you can pick like soldiers or whatever, and then just fight each other, you know, like a death match or like kind of like Call of Duty, a bunch of soldiers fighting against each other, or whatever, and then you have like zombies and stuff. So that's one thing we can do. Another thing somebody said was a platformer. So when I think platformer, I think of the classic, you know, Super Mario 64. That's what I think of when I think of a platformer, because this is what I grew up with, right? So, and look, somebody's remaking it in Unreal, so that's pretty cool. So I'm sure this one has some pretty graphics. So let's take a look at this.
Mitsutoyo is revolutionizing machine line metrology integration and palette.
Right. So we have Princess Peach here, the classic. And then, so here you're just running around, right? So on your guys is all framey, but you know. But yeah, I mean, there's a lot of things we could do, right? So let me see if I can minimize this. Is that way you guys can see it? So, you know, it's a, you know, this is a basic platformer, right? So, you know, stuff like that, things that we can do. So Mario's obviously a classic, right? So all of this stuff we can do in Unity, right? The only thing that we need is to get the characters. Now, we won't be able to like maybe build Mario, which is kind of we don't want to do, but we want to like learn how to, you know, build out the mechanics of all this stuff. For example, the sliding and stuff like that. And the animations, how do we transition between animations, and what are the restrictions, and you know, what are the parameters that will, you know, pull us into these animation, right? And so you can think of these as, you know, state machines, right? Sliding is a state, jumping is a state, idle is a state, running is a state. They're all different states, and depending on what state you're in, you know, you do something, right? So that's why, you know, in this next you know, project that we work on, I want to make something a little bit more complicated, but I really want to focus on state machines. Okay. So if you guys can, do I unpause this? So hold on, because I'm doing a screen share. So 1 moment. There we go. Cool. So if you guys have an idea, let me know about something. So again, but regardless, I really want to focus around state machines, and I would like to teach you guys some very basic weak AI. Yes? Yes, that is very true. We could. Oh well, can you do a tic-tac-toe with state machines? I mean, yeah. I mean, the state machine there would be like, whose turn is it? It would be the states, and that's just back and forth, and that's not. Yeah. Although we could do a tic-tac-toe where we train the AI how to play the game of tic-tac-toe. That is one thing we could do, using the Minimax algorithm and applying alpha beta pruning so it becomes faster and faster and faster. That is one thing we could do. So maybe when we get to the part of like when I want to introduce some algorithms for building some basic AI, maybe we'll actually use tic-tac-toe as a segue to branch and like learn the basics before we try and do anything with like an actual character. We'll use the tic-tac-toe as an example. Which one?
Code Bullet.
Code Bullet?
It's a YouTube channel. He pretty much designs AI and like teaches them to play games like Flappy Bird, stuff like that. So.
Oh, okay, yeah.
Informative, I'd say.
Yeah, like when you're building. All right, so if you use something like TensorFlow, a lot of the stuff is built for you. But if you write your own neural networks from scratch with your own neurons, you can do that. You can train it to do whatever you want. Really focus in on it. So we can do that. We can actually do that. We can teach it how to play Flappy Bird. We can teach it how to fly. We can teach it how to walk. We can teach it how to drive. All you do is give it some very basic parameters and just give it some rules and see what happens, really.
Okay.
Yes?
How familiar are you with old video games, like running on a cabinet?
What was that?
How familiar are you with old video games running on a cabinet?
Running on a cabinet? So like arcade?
Specific game where you can fly a ship, go across the land, choose right or left. Absolutely.
That's one. Yeah.
Aliens before they pick up.
I think there's also Galaga. There's also 1945. 1945, where it's just like this, and you have a character. I mean, there's a little ship. You're just moving. And it's just a bunch of shooting. Well,
but no, you get a certain view, and in the bottom right, usually there is bottom right, top left, whatever that. There is a larger view of the entire landscape, and it shows you where your pane's going. So as you fly the ship, you're in the pane, so you can tell on the far left there's enemies. You have to go over there and kill them. I can't remember that video game. It's such an old video game. I know where a cabinet's at. That's why I play it.
Oh.
I can't remember the name.
So it's an arcade game, right?
Yeah, it's an old arcade cabinet game.
So you're referring cabinet to one of those big machines, right?
Yeah, I think they made a remake for Commodore 64, or well, they had a game for the Commodore 64.
So like when I think of something like that, I think of like one of these ones where it's like these. So not like Galaga, but like.
Not a bullet hell type game.
No.
No. It's like if you elongated the space of Galaga.
Yeah.
And instead of aliens coming in groups, they would come individually.
Mm-hmm.
And as time progresses, more and more aliens would come.
Oh, I see.
So you have to run back and forth with the ship side to side, and then shoot down the aliens before they take the people off screen. They'd go down, pick them up, take them out.
Oh, this is pretty cool. Yeah. Well, so for today, I guess what we'll do is we'll work with some basic state machines. I'll do like an introduction on like how I like to build my state machines and why. And we'll apply it for a very, very basic state machine that I think everybody has to interact with every day of their lives, right? And that is a street sign, right? The stop signs, red, green, yellow. That in itself is a state machine. There are 3 states: red state, yellow state, green state. So I will create right here on the fly a state machine that mimics a light, a stop sign light. What are they called? Light? Signal light? Yeah, okay. Signal light, I don't know, stop light. Okay. Traffic light. Even better. So this set this is 2D, and then
We found the game.
what's it called?
Defender.
Defender. Why that actually sounds familiar. Defender. Cause I used to play a lot of arcade games, and I don't know if you guys remember. Oh, in Arizona there was this like pizza restaurant called Peter Piper Pizza. I don't know if you guys. It's kind of like a Chuck E. Cheese, but I don't know if it's native to Arizona or not.
Found Fast and Furious cabinet in Sacramento.
Oh yeah, there are those ones. Yeah,
It's really hard to find.
they're at usually they have those at Round One. That's an arcade I like to go to. Defender.
Under that Fat Duck.
There's an arcade place in San Jose. Pretty nice. Defender. Ah, so like one of these? Like that?
So on the top you see the white brackets, that's your current view.
Ah.
And then you apply that shift down below, that's your main space. You apply that shift left and right.
Uh-huh.
You can speed or slow down. You can destroy your ship by running into an alien, or an alien can destroy your ship. And you shoot to kill the aliens before they take the object off screen.
Is the view moving left to right?
So yeah, as you move with it, and then you can move your ship in the view. You just can't move out of it. So your ship can be centered and your view moves left to right. So you can move your ship to the corner of the view and then move left to right.
Okay.
And then up above is like a whole map view.
Uh-huh.
And then there would be green dots in the area that's not in your view, outside of the white bracket.
Yeah.
That would show that hey, there's an alien over there.
Interesting.
You have to fly to that side of the screen and kill it. Or you can shoot off screen to see if you can kill it without being in the same view.
Nice. And so this entire thing that we see here in the blue square, so everything we see,
Entire landscape.
that's the entire level?
Yeah, the level's landscape, yep.
So you start here and you slowly work your way over here?
Choose a random spot and you can stay in that entire area. You have to go everywhere in that area.
One of the games to clear all aliens, right?
Yeah, you're defending the land.
Exactly.
So,
Same spot the entire time.
You go back and forth. You face the land.
oh, so you go back and forth, up and down, up and down?
Uh-huh.
So how do you make it move to the left? You turn your ship around?
Yeah, you have an option to move and guide the ship.
So you hit like a button and the ship flips and it goes the other way?
Uh-huh, and it flips, and then you have a
Oops.
shooting button.
Ah.
And then you have an acceleration button. So you can flip, shoot, and accelerate.
And so you can accelerate this this white part right here, this view?
Yeah, and then it would have an animation for the ship to speed up.
Oh,
But
okay.
if you're not careful, you can crash into an alien and destroy your ship.
I see. That works. We can make that.
I like Defender.
We can do that. Only if you come to the meetings more often.
Well, maybe I can come to Tuesdays more often.
Yeah. I threw these up on YouTube so you can see your creation happening right here. All right.
I have to leave early because my work starts at 5.
No problem. Okay. So that's another option in favor of Defender. Raise your hand. This is sprites, right? So all of this is straight sprites, which is nice because now you guys get to learn how sprite animations work, how to work with them, right? So if you guys don't know what a sprite sheet is, this is what a sprite sheet looks like. So this is like generally done for like 2D stuff, though you can use sprite sheets in 3D, get some really cool effects. For example, in Overwatch, the muzzle flashes are sprite sheets. That's what gives them that really cool flavor. It makes it look kind of like, I'm not entirely sure what kind of effect this is, but for example, what's her name? Cheers, love. Tracer. The muzzle flashes are sprite sheets. So is what's her name? May? No, not May. The other one. The one with the mech. Eva. She has her blasts are actually sprite sheets. So if we look over here at Overwatch, Tracer, muzzle, flash. Let's see if that pops up. Yeah, so as you can look here, these are sprite sheets. These are actual sprite sheets. And what a sprite sheet looks like is this. So let's look at a sprite sheet. And it's just a series of images, right? So here is a sprite sheet. Now here's the top. So now look here, and then look over here, and then look here, and then look here, right? So from left to right, this gives it the illusion that it's walking. It's like a frame by frame by frame. So if you guys ever played like Pokemon, like on the Game Boy Advance, stuff like that, or Zelda, one of the originals, right? Link to the Past, Link's Awakening, stuff like that, right? That's all in, they're all using sprites. They're not modeled. This is pixel art. And I have a really cool, oh, not on here. I'm not on my Mac. There's this really nice piece of software. If you guys are interested in pixel art, it's called Pixel Edit. It's a really nice piece of software that allows you to build pixel art like this and tile them and then create your sprite sheets and prepare for animation and stuff like that. So yeah, and it's not that expensive. Sprite sheets? Yeah, what was it? I didn't build it on my Windows. I built it on my Mac, so it's on my Mac. But I think I had shown like during the winter, I built a very basic 2D little demo of maybe what something we could do for SoDA. And for those of you guys that saw it, it was all sprite based, right? And I was using a state machine. I had to. So yeah, you're totally right. It's all state based.
Mario 64, when you just leave Mario alone, would that change state whenever he like goes to sleep?
Yeah. So what? Yeah. So like Sonic, for example, like Sonic, if you wait a little while, he'll actually he'll break the fourth wall and like actually go and look at you, and he starts tapping his foot, waiting for you, right? So Sonic has that. Yeah, all that stuff, right? So what it ends up happening is when you're in the idle state and the character's just like waiting, and waiting, there might be a timer. So once you're in the idle state, it'll time out. So after like, let's say 30 seconds, it'll transition into like impatient state or something like that, right? That's something like a cute little thing you can add, not required, but you know, that's how they add life to the game, you know, stuff like that. So as you can see here, this is for him walking. So here's his right foot, and they meet again. And then there's his left foot. And then you're just going to cycle, cycle, and cycle. And that's going to get you your walking animation. And look at this one. This is for like when he is walking, like if you're thinking about it in a 2D game like Pokemon, walking upwards, your back is shown, or the character's back is to you. And so this is him walking again, right? With his back turned to you. This one is sideways, so if he's moving like towards the left, towards the right, and you just cycle through these, right? So you guys all have seen sprite animations, right? So this thing is pretty okay. Cool. So something like Overwatch, for example, even though it's a 3D game that still uses sprite sheets, right? Because it's a lot faster. Instead of having to have all these particle effects, just have one big old image right in front of the gun where the player can see it, and then what? Just cycle through the images. Very, very fast, very efficient. So you can say muzzle sprite sheet. Oops. Muzzle flash sprite sheet, right? And here's some examples. See? And these look, you know, relatively, you know, pretty good. So you can see that it goes pow, you know. So you have this effect, right? This one, right? And what it does is what it does is you just like you pick one of these at random and you just show it for like a couple frames and then just turn it off. That's how a flash is like in real life, sort of, kind of, just a flash of light that happens for a couple of, you know, like some amount of time and then it goes away, right? And that's what you're trying to simulate here. Here's some other muzzle flashes, stuff like that. These are pretty cool, right? Stuff like that.
Do you know the game Don't Starve Together?
I've seen Savannah play that. Don't Starve Together. I have no idea what that is, no.
It's like the idea of sprites in a 3D space, but you have a fixed orientation.
Oh. Oh, that's cute.
So it's a 3D space and you can switch your camera view.
Yeah. Yeah, we can do that. Though we don't have the art for it. That's the only problem is I don't know an artist that can quickly build these things out for us. Unless any of you guys want to. What's that? Yeah. Wait. So in this case, if I were to move like 60 degrees, so if the character's right in front of me and I move 60 degrees, does it switch the sprite into what it would look like if it was 60 degrees, like sideways?
The sprite doesn't change angles. All the sprites move with it.
So they're always looking at me. So I'm either looking at the front or behind them.
They have a front and a back and a left and a right, and then they just kind of veer around depending on which angle you're moving.
Oh, okay. So they don't have like northeast, northwest. They only have northeast, southwest. Only the 6. None of the PT. Oh, okay. Because I remember I had shown you one that had a game that did that effect and was really cool. Yeah. I mean, if we can get some sprites, we can totally do that. It would look really nice.
I know there's a website that gives you free sprites, open source sprites or something like that.
Well, let's look at that. Open source sprites.
People who make Pico 8 games use it a lot.
I know Open Gameware has that. Top free game asset now. This is what happens when you're trying to make a game on a budget. Gotta find stuff. Open Gameware is really good. Some really good artists on here. We can try and look for some. So look for some sprite sheets. So let's take a look at this thing, enemy game. I don't know what this is, but let's click on it.
I do like the Paper Mario effect on some sprite games. No, like the main characters in the game show.
Okay, so this is a. I see what this is.
Part of the world.
Okay.
They have like a background out of it. Enter the Gungeon's actually 3D. It is? Enter the Gungeon's a 3D game.
Okay.
But it fixes your view, and if you change it in Unity, it elongates it. And the reason why it's a 3D game is that certain objects and how you dodge bullets and stuff, it's done through the 3D effect.
Oh, yeah.
So-
I thought you meant that like everything in the game is like actually 3D models.
Almost, it's a flat plane.
So while we figure out what kind of game we want to do, let's just do the state machines.
Okay.
So let me make sure I'm in the correct. Okay. And I'll make sure to throw this up onto our GitHub. So in case you have to leave or if you want to have access to the code, you guys can get that. Now, for those that don't know what a state machine is, let's look at a diagram, what one looks like. Here's a cool state machine. Game is running. And it looks like game running can move to 2 different states. If the player clicks pause, goes to game paused. From game paused, you can only transition out of it if player clicks resume and it goes back to game running. Now, if you're in game running and you hit player dies, right, that point, Then it goes to game over. And until game over, in order to transition out, you would need to have player click start. Game running. That's a very simple, very broad state machine, right? Or we call this a game loop because this has to do with the entire game, right? This is here's a more complicated one, right? So let's find a state machine for a character. Okay.
Did you have all these machines running in parallel?
The state machines? No, not the way I build mine. They're only one at a time. So, move that mouse. So here, let's make this bigger. See if we can make this bigger. Oh wow, and this is a cool article using that in Unity. I want to make this bigger. Here we go. Cool. So let's find where's the idle. Okay, so usually you start off in the idle state. At least if you're working in the game, you usually start in an idle state. Your character does absolutely nothing. It's just standing there. Now we have some places to move, right? So from idle, it looks like all these things are going to be based off the inputs of the controller. That's how it's going to move. So from this, from the idle state, it looks like if axis input equals 0, stay in idle. So it's just looping inside of it. So if you guys have taken, right, what was it, 135, right? 137, you did state machines, you know what this means, right? It's just transitioning into itself. It's just staying, right? Now, if you hit, looks like it says jump button press and on ground, so it looks like we have a flag. So you have to push a button and you have to actually be on the ground touching it. Then you can jump, then you go into the jump, idle jump. Right, and so then here if you jump again, you do a double jump. So hey, look, there's a state machine for double jumps. You're in idle, you jump, and then you jump again. Okay. So let's build out our state machine. So I created a scripts folder, and I'm going to put a script in here, and I'm going to call this state machine. Okay, let's open this up. Okay. Okay. Now, every time you create a script, right? Is this too small to see?
Yeah.
Okay. So every time you create a script inside of a Unity, it's always going to make it derived from mono behavior, right? So let's create our basic example here. So what I want to do is I want to delete the entire thing. And I'm going to create two different types of state machines, right? And then you guys will see why I build my state machines a certain way, right? So first I'm going to show you guys how to build it. Very basic one. Right. So we want to do a traffic light, so I'm going to call this traffic light. I'm going to open up the traffic light, reload all, that, and cool. There's my traffic light. my script. And this is going to basically have, it's a job of just, well, the state of a traffic light, right? And what we can do is, how do you transition? So let's look, a traffic light. Let's say that the idle state is when it's red, right? Or let's figure out the different types of states. There's a red light, there's a yellow light, and a green light, okay? So let's create that. So outside here, I'm going to create an enum. I'm going to call this light state. So the default one would be red. So red light, yellow, and then green. Okay. Just like that. Make sense? And then I need to keep track of that. I will default it to red. So it starts off at the red state. Okay? Now, I need to create so the state machines in this case are basically just functions, right? That's usually what it is. So I'm going to create my red state like this. My yellow state. My green state. Just like that. Okay. So when you're in the red state, after X amount of time, it should go into the green state. And from the green state, after X amount of time, it should go into the yellow state. And after X amount of time, it should go what? To the red state. And now you're just in this loop. So in order to have this iteration to get updated, remember, Unity has the mono behavior, special function called update, right? And then from here, we're just going to do a quick check. Using a switch statement, we're going to check the current state. And if it's the red state, we want to update the red state. And if you're the yellow, update the yellow. And if you're green, update the green state. Yeah, you guys see that? Very basic. Cool. Now let's go up here. And give it times for each state. So in the yellow, you'll be yellow for 2 seconds, and then, oops. And then the green state time, you'll be in there for 3 seconds or something like that. I don't know. Okay. And now we just need to keep track of the time that we're currently in our state, right? So float state time, or I'll call it state elapsed time. Maybe that makes more sense. Cool. So we're in the red state. So if this dot state elapsed time is greater than or equal to this dot red state, right? We need to do something, right? Which would be go into the yellow state. So we say this dot state is equal to yellow state, and we need to change the state elapsed time to 0, right? and then we return. Else, actually that's it. Should be like that. Or actually, no, let me make the point. So let me say this dot state elapsed time plus equals time dot delta time. Delta time is the time in between frames. And so if you just start accumulating them, you will actually get the raw time. So how many seconds have passed, basically. So this is the time in seconds between frames. And we'll do this for the yellow state as well. If this dot state elapsed time, the yellow state, this dot state, switch it to the, and if you're in yellow, you can only transition from yellow to red. So we're going to go to the red state, reset the elapsed time here to 0, and we want to return. If not, again, we want to increment the time by the time between frames. This is a Unity thing, okay? It's not a C# thing. Gotta do the same thing for the green state. So from green, where do you transition? Yellow. You transition to yellow. Remember, yellow means go faster. No, just kidding. Don't do that. Okay. Cool. Sounds pretty good, huh?
So can you not just do this inside of Unity's state machine animator thing?
You could. We're not there yet. In fact, actually, we won't even use Unity State Machine. We're going to build our own. It's more flexible because, well, we have more control over it, and yeah, that one's very tied to the animator, and the state machine we're going to build has absolutely nothing to do with Unity, actually. You can actually rip out that state machine code and use it in another different C# project that's independent of Unity. And it's kind of like we want to build, whenever we can, build reusable code, but we will use the animator state machine for the states for our animations.
So it's like resource light versus resource heavy?
Yeah. Yeah. Exactly. Cool. All right. So let's go back. Let it compile. We have no errors. Good. So everything seems to be working. Now, I'm going to create a simple game object here. I'm going to call this traffic light. I'm going to add the traffic light component here. And then I'm going to hit, because all these variables right now, the ones I want to see, are actually private. So if I right click on the inspector and go to debug mode, I can actually see them. So there's my, it's in my red state right there. I'm going to hit play, and let's just see what happens. So we have a traffic light. It's currently in the red state. It's accumulating 4 and then 5. Now it's in yellow. Now it went to red. Interesting. So something broke. Our logic's flawed. So from the red state, we said yellow. So from red, you're supposed to go to where? Green. There you go. If I mess that up. Who gave me my driver's license? All right. So red. So after 5 seconds, it should transition to the green. Now we're in green. After 3 seconds, go to yellow. Now we're in yellow. After 2 seconds, go to red, and then back and forth, back and forth, back and forth. Yeah? Not bad. Cool. Now, I don't want to have to look at the inspector. I want to see some stuff, right? This is a game, right? I want to see some stuff. So let's do that. Here's a cube. Right? I'm going to add a directional light here. So, where's my light? So, there, now we can actually see something. I'm gonna put this right here under my traffic light. Let's get out of 2D. Okay. Okay. So there's my camera. So what I want to do is make this look like a traffic light. So I'm going to elongate it on the Y. Make that, yeah, 2 looks fine. Yeah. And then I'm going to create a, so this will be the back or something like that. And then I want to create another one and make it a sphere. And these will be the actual lights. So the camera view is over there. So bring it over like that. Just make this smaller. Just like that. See? It's already taking shape. This one would be the red light. Another one for the yellow.
Do you do fractions in the editor up there? There's like 1/3 would be a lot nicer than like whatever. 2/3.
And then we do one more, duplicate this guy, so it'd be minus 2/3. This one will be green. Okay. Cool. Look at that. Nice. Who needs SolidWorks when you got? No, just kidding. No, you need SolidWorks. All right. All right. So let's create a structure here called a traffic light, and then we're gonna add materials. Create a material for the red light. Duplicate that. Call this one yellow. Duplicate that. Call this one green. Cool. So green. Let's find our green. There's our green. Right there. Drag the green onto the green. Hey, look at that. So far we have that. We have yellow. Let's make this yellow. Okay. Throw the yellow onto yellow. Oop. There you go. And make red. Pop that over into the red. Cool. Looks good, yeah? Now, there is our traffic light in all its glory. Okay. So let's hook this up. So on the traffic light, I'm gonna go ahead and just open up the traffic light script. Have a material for the red. Or another material. How do we want to do this? Should we just disable them? So the ones that aren't the current state, we just disable them? Like a gray?
Well, maybe a material with 0 albedo.
Like transparent?
What?
Make it transparent?
Yeah. Alpha, 0 alpha.
Yeah, let's do that. Material, call this red material. Hold on. No, we got to do render. The mesh renderer. Yellow mesh. Full disclosure, you shouldn't do it this way, but you know, we're doing it this way for now. Okay. Okay, so again, very bad, don't do this, but we're gonna do this anyway. If you're in the red state, we're gonna go ahead and grab the red mesh dot material dot color is equal to color dot red, right? Or we just want to change the albedos, so we're gonna say color. What happened there? Color is equal to this dot red mesh dot material dot color dot A is equal to 1, so like 100%. If you hover over A, I'll tell you that it's between 0 and 1. 1 is a fully opaque. Then red mesh dot material dot color is equal to color, right? Just like that. Now, if you're yellow or green, we want to change the transparency to, like, say, half. That yellow mesh dot material dot color, or you can reuse the variables like that. Color dot A is equal to 0.5. Okay, same thing for the green. And you know you're doing it bad when you have to copy and paste your code multiple times. So you know you're doing it bad. So I say, like, don't do this. So now we're in yellow, so we're going to do yellow. Okay. So just make sure you are setting the alpha to the correct value for your correct state. And again, don't do this. Cool. Now we just go back here. There's a couple things we're gonna have to change. First, we have to make sure that the shader supports transparency. So drag in the mesh for each of these game objects. Just drag it in here. Like that. And select all of the materials and change it from opaque to transparent. Or else if you try and use the alpha channel on it, it won't work. Hit save, hit play, and see what happens. There you go. So you can see red is fully opaque, the others are transparent, and then from red we go to green. There you go. See that? Now you're yellow and then red. Very cool, huh? Right? And that's a basic state machine. Right? Now the problem is that one, it's not reusable. We have a lot of code that's just, you know, everywhere. So this is not good. It's not scalable, right? So bad, very bad. But hey, it works, right? Let's try another approach. let's try and let's try to work on this first, right here. How can we make this? How can we make this like neater, right? Huh? Not putting in an update. So what we're going to use is we're going to use a dictionary that will contain all of our states. So your private dictionary. The key is our actual state. So we have our light state. What is the value? It's actually a method. So we can, methods can be passed around as values. You can pass a method to another method. You've seen this in C++. Java, you can't do it. I don't think so. No, I don't think you can. You have to wrap it around an interface because you can only pass around objects in that way. So yeah, you can't do it. Maybe you can now. I don't know. But in C# you can, using the system.action. We're going to call this our states. Cool, just like that. Now, we need to subscribe. We need to add them in. So in my start here, I need to register these methods into my state. So I'm going to say this.states.add, and then right away, Visual Studio's, with all its glory, wants to help me out here. So the key is going to be our actual state, right? Our state type, not the actual state that we can actually invoke the method. This is, state type. So we want to say, hey, I want to add a red state. And here is the method, red state. Just like that. That looks pretty cool. And it makes sense when you read it. States, add, red state. Cool. Here's our next one. We're going to add a yellow state. We're going to pass in the yellow state. This is the method, right? The function that's going to be called. The method, because it's a, instance, a reference-based function. So here we go, green state. Just like that. Now, right, I can go down to this update. Right here, and I can delete this entire check. I no longer have to do this. All they say is this.states, and in a dictionary in C#, the key is you use the square brackets kind of like you would an array, and you say this dot my current state, which is the state. Now the value is a method, the signature. So how do you invoke it? Well, there's a couple ways you can do it. You can say dot invoke, so I'm invoking it, or you just say like that. It's cleaner, right? And look at that, I just eliminated the entire switch statement by using a dictionary. And it's gone. That's very clean. This.states, this.state. Or if you want it to be more legible, you can say system.action current is equal to this.states, passing which state we're actually in. Right, this is the current state, current.invoke if you want it to be really legible, or you can say current, like that. Either one. Let's do it as current.invoke, just so we can, see it and what's going on here. So if you wanted to make it even more legible, we can say this, make this current state. Right there, current state. There. All right. Now let's go back to Unity. Hit play.
and nothing should have changed. We just ripped some things out, right? Hit play. And there you go. Same thing, right? You're red, 5 seconds, you go to green. After 3 seconds, you should go to yellow. After 2 seconds, you go back to red. Very simple, right? Now, unfortunately, states have states, okay? As of right now, we have no idea when we actually enter a state. Well, that's a lie. We do. Right here. Right? But you know, everything is going to be inside of this little block. So there's no way for us to, you know when we first transition into a state. So in a state machine, you should have your states, how we have here, but really, you should have another method or a function, depending what language you're working with, that has a transition state method. So let's try that. So here I created this method called transition state, and you need to pass in the next state you want to go to. So this is our transition state logic here. So every state, when they're done doing their thing, they should put in a request to get out. Basically, for example, if you're in the jump state, you hit transition state, and then from transition state, you say, hey, I want to double jump. But what if you can't double jump because, you have some kind of effector on you that prevents you from being able to jump again? So when you go and you do a request for a transition state, there should be something there that will check first to be like, all right, can you transition to this next state? And if there's an effector that says, no, you can't because, maybe you have some goop on you, you can't double jump, then it gets rejected. And you can't transition, and something else should happen. So that's what transition states are usually for, okay? So in our case, we don't really have that, right? So here in the transition state, we'll actually say state equals next, and the state elapsed time, we'll reset it here. Because right now, the states are actually doing that. You see that? So what we should do here is we should say this dot transition state and go into the next state. So from green, we want to go to yellow. You see how this is making more sense now? Yeah, as you start reading your things, it's starting to make more sense. This dot transition state into yellow. Green should not have the authority to do it. Green is just going to put in a request. Hey, I would like to transition to yellow state. Then the transition state would be like your last ditch effort to do a check, right? Now, transition state, like if you're working in a game, right, that's what we're trying to build up to, you will have usually monitors on your character monitoring different states. For example, you can have a monitor to check all the effectors, right? So if you play like League of Legends, you have all these buffs and debuffs. So when the character tries to do something, right, that state that allows you to hit, like let's say hit your ability, it's going to request, hey, I want to use this ability, but then it's going to go ahead and check the monitor, like check debuffs, can transition to this state, and then in it will just loop through all the debuffs that it has and see if whether or not you can actually pull off that move, and then it'll just return false, and nothing happens. Maybe if it returns false, you will have like a little thing on the screen saying, you can't use this thing right now. For example, you have no mana, right? League of Legends is actually a very good example of a state machine because when you hit the little buttons, you hit Q, for example, like in your own Morgana. You hit Q, you have the little reticle. You're in the state to just about shoot that skill shot. If you hit the mouse, when that happens, when you hit Q, it's waiting for that mouse click or the input to activate the actual skill, right? But when you're not there, if I hit left click, does it shoot a skill shot? No, because nobody's listening for it. So, that's a good example of a very small input state machine. All right, so let's update the rest here. Transition state. So from yellow state, we go to red. And then from red state, we go to green. Okay. Now, remember what I said? You're writing bad code when you're constantly like copying and pasting. In our transition state, we can now check the material stuff once. So we can go ahead and like all this, the color stuff, the thing that changes the color, we can now remove this. And we're going to put this in the transition. Okay, so I want to copy this, delete that. So now look at my state machines. The actual functions, they're a lot lighter now. Look at that. Very light. My transition's about to blow up though. There it is. So we're going to create a color. Or we're just going to say, how do we say this? All right. So we use another switch statement. So if the next or do a case statement. So if you're red, do something. If you're yellow, do something. If you're green, do something. Okay. So I just want to change the alpha on this color. So we're going to say var color equals this dot red mesh dot material dot color dot, well actually yeah, just, this is bad, all kinds of bad. All right, we'll just do it this way. So we're going to dump it in here. We'll go off and fix this, but this is bad. This is bad what I'm about to do. This is bad, all kinds of bad. Yeah, it's all kind of bad. I'll never understand why that never works. Okay. 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 So in here we have the red. It's going to change that. So this needs to turn into yellow. This will turn into yellow. This will turn to red. This will turn to red. Let's turn to green. Green. Red. Red. Okay, cool. All right. So now the color change will only happen once, only when it transitions, versus it changing every time. Right? How I said that's not a good idea. Right? Changing the color constantly is not a good idea. Just change it once. Okay. And did you guys see the problem there? So right now you see how all the transparencies are fully opaque. So when I hit play, I'm in my red state, but I never transition into the red state. So it's red, but all the other transparencies haven't changed. Now it's green, and now it's going through what we thought it should go. Right? So you see now it's working how we thought. Now the reason why this is happening is because I never called transition state from the very beginning. So ideally, remember this light state is an enum, and the default state is red. When you have an enum, it's always a good idea to have a none or unknown state. See? Change these to 1, 2, 3. Now, the default state for our traffic light is unknown or none. And then what we're going to do is after we initialize our states, we're going to transition into our initial state, which would be red. So now we hit play here. You will see that the transparencies work properly now. See? Because in the beginning, we went from a state of none, and we transitioned over into the red state. So what does that mean? If you have your state machine, you need to initialize it. All state machines must be initialized. If you just have a state machine, you just try to kick it off. What is the current state of the state machine? It's in an unknown state. Right? So in our case, it was a beautiful example of our state machine being in an unknown state, and it was just doing something. So not what we wanted. So when you have a state machine and you build it, you need to what? Initialize it to something. Okay? And now this is working how we would expect it to work. Cool. So now every state that we have here has gone down in code size, and the transition state is the only one that has blown up a little bit. Okay. Cool. Does anyone have any questions about that? Now, this is pretty good. It's pretty nice. The problem is all of our efforts of building this, little state machine is not transferable, right? If I wanted to have a state machine for, a crosswalk light where you push the button and then there's a state machine, right? It blinks and then stops blinking. I would have to rewrite this dictionary. You know what I mean? I have to start all over. And so what's something that we can do? Enter, the way I build state machines is you decouple. Zero dependencies here. You build it in such a generic way that you can now, if you build it this way, you can apply a state machine to whatever the heck you want, right? So if you need to build a state machine for a traffic light, you can using this method. If you want to build a state machine for the crosswalk, you can. You want to build a state machine for a bridge going up and down, whatever, you can using this. Okay, it doesn't matter. Make a character that has different states: Mario, idling, jumping, double jumping, crouch jumping, crouching, crouch walking. You get the idea. You can do it this way. And then you have different characters doing different things, and they're all going to have their own states. Okay, and this allows you to not have to reuse code, right? Because once we build out the state machine, it's going to be the code will be quite long, right? And it's going to be generic. Okay, so we can adapt this to whatever heck we want. Okay, so let's do that. So what do we need first? We're going to need a dictionary, so we need to import a generic namespace. We could use a hash table, but I prefer using a dictionary. But you can use whatever you want. Because a hash table, I mean, I don't know. Honestly, I don't know. No, I think with a hash table, I think the values that you actually put in it can actually be, like, they're just objects, I think. If I remember correctly. Hold on, let me just whatever. Make a method here. Hash table. Yeah, see, hash table is generic. So you can't use the generic one. You have to use the collections one, and then you have a hash table. See? And if you add hash table h, whatever, h. If I want to add something, the key is an object, and so is the value. So maybe this is good. Maybe this is good for you. Maybe you want it to be like that. Your key could be anything. It could be a string, it could be a number, it could be another object. The actual value that hash table holds could be, it could be a key, it could be a string, it could be an object, it can be another hash table. Who knows? The reason why I use a dictionary, now it's coming back to me, is because I already know what my key, I already know what the key is going to be. And the keys that I use are strings. Right? You can optimize it by not using a string and using a hash of a string. Although you have to be careful because you can have collisions. So dictionaries are pretty good. Plus, I know what my value is going to be. My value is going to be a function. And the function, the attributes, or not the attributes, the parameters are going to be known ahead of time. So I already know the entire layout. So I'll just use a dictionary just to make my life easier. So I'm going to say public class state machine implements or extends system.object. And that's not necessary, but I always do that. It's a habit of mine, and it'll probably never go away. So private dictionary. What is the key? It'll be a string. So the states will have an ID with a string. What is the value? It's going to be a system.action. However, I need to pass a parameter in it. And that parameter, it's going to be an enum. So I need to fix this. So I'm going to just call this my states. It's equal to that. So I need to create my enum. It's going to be called my state. It's literally a state. What should I call it? It's always so hard to call these. State. Yeah, I'll just call it state. Well, no. State type, I guess. I don't know. Anyways, I always have an unknown state. I have an enter state, so you're just entering that state. I have an update, so the state's being updated. And then I have an exit state. You're currently about to leave your little state. Just like that. And so now in my dictionary, this is what I want to pass in here, is I want to pass in state type like that. So I need to fix this. So the method, I will be passing a state type. We'll be passing an enum. Now I need to keep track of my current state. And that's a string. So I'll just call this state ID. And I'll set this equal to an empty string. Okay. All right. Cool. Now, I need to create a property so you can actually get the state ID, right? So say public string state ID get return state ID. And that's it for that. Now, I want to be able to change the state ID, not with a .set ID. I want to be able to set change the state by using a setter here. And the way this is going to work is basically I want to be able to do something like this. I want to be able to say this dot state ID is equal to, and I can call it attack state. I want to be able to change states like this. Instead of doing something like this dot set state attack or something like that. You know what I mean? I want to be able to just do it like this. So how do I do that? Well, like this. Use properties. You have a getter and a setter. But how do I do this? You know, I have to check some stuff, right? And the way I check is I need to have a transition state. So I'm going to make this protected. And call it transition, and then transition to that state. The string, this is the state ID. So this is the state ID that is being requested. So inside here, I'm going to say this dot transition value, because the value coming in is a string. Remember, this is just C# syntax sugar here. So don't, you know, you could accomplish this exact same thing like in Java. You would say something like public string get state ID. And then to do what the setter that I'm trying to, you know, build up here would be void public void set state ID string state. And we just say this dot transition state. See, usually in a setter, you set things directly. Here we're not. Here somebody's requesting to change the state. So in order to do that, I need to send that state that they're requesting. I need to send that to the transition state and let transition state handle whether or not I can change from the current state that I'm in to another one. Okay. Oopsie daisy, don't want to do that. Now, how can I figure out whether or not I wanna like how do I figure out whether I can or cannot transition to another state? So that's a interesting question, right? So we'll answer that question next time. We're running out of time, but I want to be able to at least build this part up. So let's check a couple things. So now what happens if they accidentally pass in a null or empty string? Do we care? Right? Maybe we do, maybe we don't. So let's do that. Let's check first that the state they're actually sending us is even valid. So if string.is null or empty state, we return the state that they want. Like, let's say they say this.state ID equals null. We're going to reject it because it's empty. I don't know what state you want me to go to. It's null. I can't do that. Or the string is empty. I can't do that either. Next, check if string.compare the current state ID with the state, the one they're requesting us. If they're the same, 0 meaning, so the way compare works is that compare will return 0 if they're exactly the same. Else it'll return 1 if state ID comes first alphabetically, or -1 if it comes after. So if you're checking A and B, here it would return 1. If you're checking B and A, it would turn -1. If you have A and A, it will return 0 because they're the same. And ordinal counts as well, so capitalization. So if they're the same, return, right? Unless you actually, can you transition into yourself? Like if you're in the running state and you transition to running state, what does that do? Right, so you can fix this, you can change this if you want, right? For right now, the rule is you can't transition into the same state. Right, on a state diagram, you have the thing where it's looping back, right? But that's not transitioning to the same state, it's just staying there. It's not really going out and then coming back, it's just there, it hasn't changed, it's just there. You use the little loop back to just show you, graphically, hey, we're going to stay in the same state. But if you need to know that you're going to transition into the same state, well, you could do that. But in our case, I kind of just want to ignore that. Okay, so the state, we have done some validation. The state that they're requesting is not null, it's not empty, and the state that they're requesting to transition into is not our current state. So what do we do now? First, check if this dot states dot contains I'm sorry, we need to do one more check. If the state that they're requesting to has not been registered into our states, then we have to return, because that state is not valid. For example, you're Mario. You have idle, walking, running, and jumping, but you don't have transform into Megazord. Well, Mario doesn't have that power, right? So he can't do that, So what happens? Well, you just ignore that request, right? There's nothing for you to do. In fact, all these returns, what you should be doing, you should be logging to the console, warnings, be like, hey, I didn't transition to the state because, and you give it a reason. That way, when you're like, hey, my thing's not working, you can look and be like, maybe you misspelled something, or maybe your logic is flawed. Or maybe you're trying to request a state that you have, but maybe you haven't registered yet. That happens. All right. Cool. So let's grab the current state. Current is equal to this dot states dot okay. Let's check. There's a base case here. Remember, when we're first initializing the state machine, it's possible that when we check the state ID that it's null or empty. So we need to make sure that it's not. So if it's the case that the current state, our state ID is not null or empty, we can do some stuff. Okay? And what we want to do is we want to notify the state that, hey, you're about to exit. And how do we do that? We say this dot states So here, all we're trying to do is we're going to let the current state that we're in, that, hey, you're about to exit. That way, it has some time to prepare. It gets notified, hey, you're about to go into you're about to leave. We're about to leave from this state over to some other state. It doesn't know which state, but it just knows, hey, we're about to leave your current state. We're about to transition out. That way, you can do some stuff. Maybe you save some data. Maybe you play an animation. Maybe you play a sound clip for some reason. I don't know. Whatever you want. But here, we're notifying the current state, we're about to leave your state. Now we're going to say this dot state ID, and this one's the lowercase one. Okay, this is lowercase, not capital. This is lowercase. We need to actually change this value. Okay, if you use the capital one in this case, it's going to go here and you're going to have this looping error. So you don't want to do that. You'll have an infinite loop. So don't want to do that. So you can say this dot state ID is equal to the new state, just like that. Okay, and then we're going to say this dot states, our actual states. We know it exists, so we don't have to really check anymore. We're going to say invoke, enter. Let it know, hey, we just entered your state. Let it know. Just like that. Does that make sense? All right. Cool. So that's pretty good. Now, we need to update our state. We need to update our state machine. So we're going to create a function here called update. And whoever has this state machine as a reference needs to call update, or else it won't update on its own. Right? So somebody needs to tick it. And we're going to say this dot states. Ideally, this is what we want to be able to do. Update. We want to just call update on it. But here's the problem. What happens if the state machine, it's in an unknown state? Or the state, for example, is empty or null. So we need to keep track of that. So let's go up here. System.action. This has our state type. We're going to call this current. Set this equal to null. Just like that. Now we're going to go back down here. If it's null, we're going to hit return. If not, we're going to update it. So your current state update, just like that. Now, if you don't want to do this, right, to do this check if it's null or whatever, you can say this dot current question mark invoke, and that's basically syntax sugar for what I just did. But you can write it all in one line. Okay. Now, here we need to update this. We can say this dot current is equal to this dot states, just like that. And in fact, we don't even have to check the string anymore because it's actually slow. So we would rather just check to see if this dot current, if it doesn't equal null, or actually we can just do this now, right? We can do this, question mark. Let it know we're about to exit. Notify the current state it's about to exit. Change the internal state ID to the requested valid state. And we can also remove this. Okay. And we can say grab the current state, notify the current state we are about to enter it. Just like that. So let me add some comments here. If the state requested is null or empty, return. If the current state and the requested state are the same, return. If the requested state has not been registered with this state machine, return. Okay. Update the state machine state. Cool. Here we go. Return the state ID. Attempt to transition to the requested state. Cool. Nice. Not bad. Not bad at all. So how would we then be able to use this in our traffic light examples? Let's go back to Unity, see if everything compiles and we don't have any warnings here or any errors. Okay. Cool, everything looks good. Now how can we update our traffic light now? I can go here. I can now remove these states that I have here. Okay, I'm going to create a state machine. Call this state machine is equal to new state machine, like that. And oh, I didn't have a way to add, so I need to add states. So I'm going to say add string be the state ID followed by a system.action with the state type. Call this our actual state. And we'll do some quick checks here. If this dot states dot contains key state ID, return. We can't, add, the same thing. Actually, what we can do is, if it does contain it, maybe this is what they want. Actually, no, let's not do it that way. Let's do it this way. If it doesn't equal to it, we're going to say this dot states dot add the state ID, pass in null for now, and then we're just going to say this dot states, because at this point we know it exists. So we say state ID is equal to the state. That way, if it already exists and you hit add, it'll just update it. It'll swap it. And if you add, you should be able to remove string state ID. Actually, you need to do a check. You can just say this dot states dot remove state ID. There, gone. Purged it. Gone. Cool. So we'll go back to our traffic lights. State machine. Now we have this whole like red, yellow, green, but we don't have that anymore, right? Now we're using strings. So you have red, you have yellow, you have green, state machine dot state ID, initialize this to red, and now these ones just need to have a state type. Call this the current state. Now we can say, okay, if, well, you should use a switch statement, switch state. The only one we actually care about is if it's updating. We'll go ahead and just grab all this, go like that. And we no longer have this transition state. What we do have is this state machine dot state ID. From red, we want to go to green. See that? From red, we want to go to green. And we're just going to update all of these like this. So this needs to have a state machine, state type, state. And then this one is just going to want to go to, from yellow, we want to go to red, yellow state time. And next time we'll clean this up even further. We can clean this up even further. So state machine dot state type, state. Whoa. Green state time. From green we want to go to yellow. Gonna delete. Well, so you see this transition state stuff? Remember how we had to change the colors? Check it out. Now we can actually purge this, all of this. Because now we know state. So first in the update, we're just going to call update, let update. And now here's the way we're going to do this. We have the events when we enter and when we exit. So we can just do something like this. Enter. When we enter the state, we're going to say color is equal to this dot red mesh dot material dot color to alpha. Make sure it's at 1. Red mesh dot material color is equal to color, just like that. And when we exit, we're just going to do the reverse. We want it to be at half, right? So I'll never understand why this is always a problem. So exit color, I guess we'll call it exit color like that, exit color, and then call this enter color. I'll never understand why. It always gives me an error. But anyways, yeah. So here each stage it's only going to affect itself, its stuff. It doesn't affect the other ones like the yellow and the green. You want to have that. You want to be like, all right, this state only handles that particular state stuff. Everybody else, handle it yourself. Okay, unless you need to, but generally you want to decouple as much as possible. Okay, so we need to do the same thing for here. So I'm just gonna copy this stuff. Oopsie daisy. So here's the yellow state. Paste that, change this to yellow, change this to yellow, do the green as well. Where's my mouse? Okay, here we go. Do this to green, green, grab the red, or the exit. Okay. Change this one to yellow, yellow, green, green. Okay. Just like that. And the only issue now is that I have to initialize all the colors to be transparent, or else they're all going to be opaque, and we're back to that same problem. Okay. So I need to create a called initialize graphics. So we'll do that in the awake. So when we awake, initialize graphics. Inside of initialize graphics, basically going to do this. We do it once. We set all of them. So this one would be at. Actually, we can just. Actually, we could have just done set material transparency float alpha mesh renderer mesh var color is equal to mesh.material.color color.a is equal to mesh dot oops, I don't know what I'm doing. Alpha right, and instead of having all of this junk, I can just say set material transparency to 1.0 before entering. Oh, and I have to specify red mesh, just like that. Here we're exiting. Set material transparency 0.5. Dot red mesh. See how I just pulled this similar code out to its own function? So that'll make it a lot neater. This dot yellow mesh. Oops. Windows. Come on, man. Dot set. Dot green mesh. Okay. And now to initialize them. So here I just say this dot set transparency 0.5, this dot red mesh, and I'm going to do this for the yellow and the green. Okay, so when it awakens, it's going to set them all to half transparency, and at the start I'm going to register red, yellow, green states. I'm going to initialize my state machine to be in the red state. And so when the state machine, it should enter it, it should change the transparency to a full alpha, the alpha to 1, meaning fully opaque, so we can actually see it, and it'll just be going how we thought it would work, how it normally would, right? So now we just hit play. Oh, and then we no longer need this. That's gone. Because now all of that's inside of our state machine. So our code now is looking a little bit cleaner, right? So some things have changed, but it's a little bit cleaner. But the most important part is that the state machine is now decoupled. Notice this, we didn't have to do anything else. Like inside of this state machine now, everything that has to do with state machine is now inside there. All we're doing is we have these states, and we're just transitioning between them, doing these little state ID requests and stuff. So let's try it out. All right, traffic light, hit play. So now we're in red, right? Should go to green after 5 seconds, and whoa, that's interesting. So what happened here? Yes. Once we transitioned, we never set the time. We never reset it. So when we enter, we're gonna say this dot state elapsed time equal to 0. So when we enter, we'll do this. That's why it happened, is because we didn't reset the clock. Now we can have our state machine actually have how long you've been inside that state, and we can just check against that. So there you go, green after 3 seconds or whatever, we get yellow or whatever, and we go red. So you can see, if we go into the inspector view, hit debug, there's a state, our little, it's a little clock. It's going around like that. And we can even see our state machine. So if we stop this, go back to our state machine, if we add the attribute here, serializable, just like that, whatever can be serialized will now be serialized. So you should see the state machine pop up here. There it is. The only thing that we can see now is our state ID. That's the only thing that's serializable, the string. So you can see it's red, and it should transition to green after 5 seconds. There, now it's a green. You can see right there, after green, it should transition to yellow. From yellow, transition to red. And that's our state machine. Now the state machine that we built has nothing to do with Unity, has nothing to do with traffic lights. So we can actually reuse this state machine for other purposes. Okay? Cool. All right. We'll work on this some more next time and do some more examples with it. Cool. All right. So that's it for this one. So I'll see you guys on Thursday.